All right, 7.2 continue. So this was the law of sines for the ambiguous case. So we might have no triangles, might have one triangle, or you could possibly have two triangles. So let's see what we get out of this one. Solve triangle ABC. If angle B is 55 degrees, side B is 8.94 meters, and side A is 25.1 meters. All right, so the first thing I'm gonna do is draw a triangle and get an orientation of what I have and what's missing and what formulas can I use. So again, how you label your points in your triangle, it doesn't matter as long as the sides opposite agree with the corresponding angles. All right, so I see what is missing and what can be solved first. All right, can I do, let's say, I have the side A, side B, I'm missing side C. Can I do A squared plus B squared equals C squared? No, right? This is only for right triangles. Not doing right triangles in this case. All right, so if I look at angle A and angle C, there's two things that are missing. I can't solve for either one, right? I just know that the sum of A and C has to total 180 minus the 55, right? All right, so I'm forced to solve for only angle A using law of sines, right? That's the only thing that's available for me. So again, remember, if you're forced to solve for an angle first, there may be two possible values of that angle, right? The one from 0 to 90 degrees, and it might be an obtuse one from 90 to 180. So law of sines, we would have the sine of 55 degrees over 8.94 is equal to the sine of A over 25.1. We cross multiply and we get the sine of A would be equal to 25.1 times the sine of 55 degrees. All of this is divided by 8.94. If you need to do more steps than what I'm showing here, feel free to do that. This is some basic algebra to isolate sine of A. All right, so we're looking for this angle. So I'm gonna have to use my calculator, right, to approximate this angle. I don't know exactly that value right there, if it's one of those special angles. No, it's not one of those nice numbers that angles we're familiar with. So in the calculator, I'm gonna rewrite this as the inverse sine of whatever that value is. I'm just gonna leave it as it is. It's gonna be some decimal, right? So if I evaluate it first, then I have to round that decimal, and then the inverse sine of that decimal. I might get slight rounding error. So I'm gonna just type it in exactly as I see right there. Make sure your calculator is in degree mode, right? We're dealing with degrees. So I have the inverse sine of 25.1, sine of 55, close that, divided by 8.94. And this gives us an error. Make sure I typed everything right. Let's go back and just see. Looks like it. The inverse sine of 25.1 times, I didn't put the time symbol, but it's not necessary. But if you want to make sure that's the case, insert times. My argument is 55 closed divided by 8.94. I want to close off that entire argument for the inverse sine. I could do that. There you go. And I hit enter again. Oh, error again. Why do you think I'm getting an error? Watch this. Let me take off the inverse sine and see what all that parentheses of this big quotient is. Oops. Do it again. That number right there is bigger than 1, right? So what angle has an assigned value larger than 1? None will, right? It's always between -1 and +1. So this gives us an error in the calculator. So this tells us that there is no possible value for A to exist. So no triangle can be formed. With the given dimensions. So again, if you had your protractors and the rulers and you're measuring out this really precisely, you can see that you can't form a triangle. You can have a triangle that's going to have one leg too short. Well, not even a triangle. It's going to be something like this, perhaps. So missing some information. Not enough length on one of the sides. Again, draw the picture. So you can see you have this angle and opposite this angle, so law of sines can apply. And I have angle C and side C. The only thing missing there is angle C. We're forced to solve that, right? Because angle B and side B are unknown. So I'm forced to find the angle first. I have to consider if two triangles can be made. All right, so now I start with law of sines that a sine of 43.5 degrees over 10.7 is equal to sine of C over 7.2. You cross multiply. Seven 7.2 times sine of 43.5 degrees divided by 10.7. The inverse sine of all of this would be C. So just type exactly what you see. 7.2, really don't need extra parentheses for all this, since it's all multiplication in the top, and then divided by 10.7, single term. All right, so we got a 27.6 degree angle. All right, so triangle one. So I have angle A is 43.5 degrees. angle B, and angle C we just found to be 27.6. So 180 minus these two gives us angle B. $108.9. Little a, b, c. We'll come fill these in just a second. If we determine we have two triangles, we can go back and see if we need. Angle A is still fixed to be 43.5. Angle B, we don't know yet. Angle C could not be just 27.6. It might be, you think about sine. Sine can be positive here or here, right? And the triangle can be from 0 to 180, right? So this is the acute angle. So the obtuse angle might be somewhere over here, which is that's the reference angle of 27.6 from 180. What's that going to be? I'm not going to rely on my brain today. Let's see, 180 minus 27.6. 152.4. So if I put C to be 152.4, is there room for angle B? You can automatically see that's what, 195.9 degrees total just with A and B. So there's no room for angle B in there, right? So we know we only have one triangle. So we go back here and fill in the remaining parts. We got 10.7 for A, C was 7.2. So to find B, look at the picture, I just realized that you can use law of sines again to find side B. So we'd have sine of 43.5 over 10.7 is equal to sine of 108.9 over B. I have the answer up here, so I'm not going to let y'all just watch me type in buttons on a calculator. You have to do that, right? So I have B is going to be approximately 14.7 inches. Back up here, 14.7. So B is the longer side, so opposite side of this angle must be the larger angle, right? 108.9, that works. Next larger side, next larger angle, that works. Everything is in agreement to where that's not always necessarily that you have to check that. You just kind of make sure that your arithmetic was done correct, right? So if I would have got B to be 5 inches, that's wrong. Something's wrong, right? Because of the dimensions. The bigger the angle, the wider or the longer the side is across from it. Yeah, so A is 104 degrees, side A is 26.8, and side B is 31.3. If I say solve the triangle, you can go through the process, draw in the picture exactly what he's had, but just look what's given to you first. This is an obtuse angle, right? 104 degrees. So angle B and angle C have to be acute angles, right? They got to be less than, the sum of them has to be less than 76 degrees total, right? So this is the larger angle, right? Why is A smaller than B? So this tells us we can't have a triangle. A triangle. So again, you can go through all the arithmetic and the recipe and the following the law of signs and solving, and you're going to see you can get an error in the calculator. All right, so that is the rest of 7.2. The procedure is the same for every one of these. It's just that if you have to solve for an angle first, you must consider that there may be two triangles that can be formed. Any questions?